Utopia, dystopia, and today's technologies hosted by Johannes Katzner, bringing a global conversation discussing technologies that affect us all.
Hello, my name is Johannes and I am the host of this show. Today I'm here with Srijit Panja and we will be talking about the human brain or the animal brain and consciousness and intelligence as they occur in AI systems and the difference between them and the various designs that might lead to a more brain-like AI system. Srijit is currently a data scientist at Cognita AI. Prior to this, he was associated with software engineering and data science wings of Ngave Nirman Technologies, Infogain, India. He has been an Indian representative to the United Nations Development Programme, SDG AI Lab, IICPD Turkey as an United Nations volunteer data scientist, and has been credited for his work on Vilokana, the Indian COVID search engine, featured in news by Times of India, New Indian Express, Economic Times, The Hindu, and Hindustan Times, among others, and mentioned internationally in the Nature Journal, which was launched and had been operational during the first COVID wave in India. Srijit's early research interests included computational linguistics and natural language processing. His early works as an intern with NeuroAGI Lab, IITM, Nazarbayev University, and startups like ClueTrack, B-Aegis were in the area of NLP. He is now inquisitive of brain-accurate, not brain-inspired, neural networks, and is immersed in reading works of Jeff Hawkins and Numenta book 1,000 Brains and neuroscience resources, mostly hosted by World Science Festival and TEDx, among other sources. Okay, so this leads perfectly to the first question, which is, how do you see the difference between brain-like and brain-inspired artificial intelligence systems? And do you see this important difference that I've also discussed with Utpal Chakrabarti recently on the show, also with Christian Wilk and other guests recently. This has been this, you can see it as a sort of series of conversations that I've been having around these topics. But I want to ask you about your research and what you're working on there, and also how you see this important difference, and also, of course, consciousness fitting into this equation.
Okay, sure. Thanks for having me and giving me this platform to speak my head out. So it's actually a very untapped kind of a discussion. We see AI progressing mostly in the direction of brain inspired neural nets, brain inspired mechanisms and everything. Whereas currently, maybe from some time back, we're seeing some more improvements in the AGI space and everything, and we are actually getting results in that space. So there is actually fundamental, very distinctive difference between these two routes. That is, when this thing started, basically, right from the start of when the paper was drafted by Dr. Hinton about backpropagation, and from where neural networks and everything started to crop up. Right? So the essence of that was to captivate how neurons work in the brain and to use that in a computational model. Right? But how it is done is basically in the brains as well. In the brains, the neurons get trained, right? The neural pathways that gets created when I see something, when I keep on seeing something, or keep on getting the same feeling, so it keeps on getting trained on that. So suppose I have seen something or I have touched something for a long enough amount of time. When I touch something for the next time, I can instantly recognize that this is this, right? So this kind of a training keeps on happening, and that is how the brains work on a very surface level. We might get into more depth as we speak in the discussion. So on a surface level, this is the thing that happens. So taking from that, I think what has been done in the current neural nets is to structure it in a way that we have neurons there, but that incremental process, that evolutionary process, that I should, the sense organs, or the first input layer should keep on having that layer to get trained. That is not being followed. Instead, we have some calculative methods, right? So in the backpropagation itself, we have gradient, descent, these functions. So we take help of calculus and we basically optimize, right? We take a loss function and we try to minimize that, pull that down, which is a little, more manipulative, not exactly natural, to be very precise. So that is what I think is the main difference, fundamental difference between how the root of AGI is, brain accurate computational building is, and how the current scenario is in the neural nets, deep neural nets to be exact.
So I have to ask you there a follow-up question, because the difference that Noam Chomsky locates is one where he calls it, and I want to quote this directly, because it's so beautifully formulated by him in the New York Times, I think it was. He says the human mind is not, like ChatGPT and its ilk, a lumbering statistical engine for pattern matching, gorging on hundreds of terabytes of data and extrapolating the most likely conversational response or most probable answer to a scientific question. On the contrary, the human mind is a surprisingly efficient and even elegant system that operates with small amounts of information. It seeks not to infer broad correlations among data points, but to create explanations. And I think it is in this creation, in this sense making, in this creation of explanations, that there is the difference, an important difference. Maybe there is some other differences also, exactly how the neurons are updated. But how does one lead to the other? Do you think that there is a direct path between these, I would say, deeper explanations and the more surface phenomena that we explain? The way that we explain the world, the way that we seek to create explanations, even counterintuitive ones, not ones that necessarily please others. But we like to, and we sometimes thrive on having differences of opinions, right? We don't want to predict what other people want us to hear. Whereas, right now, in the foreseeable future, I think these AI systems that we've built are precisely that, right? They're trying to match our expectations.
Yeah.
So could you speak to that? Is there a difference in design that leads to a difference of process?
Yeah. So I think it's well formulated. The only thing is, from calling them, from looking at them as statistical machines. I think with the advent of more language models and models in any space, it has moved beyond that a little. But it's not just plain statistics, but yeah, still to some extent, it takes help of large corpus of data that is available online, that is open source or somehow retrieved and everything. It takes help of that, and from that tries to generate. Right? From that, the credit goes in those parts where it is, even from understanding from large sets, large collections of text or these things, it is being able to generate its own answers. Right? And how that is happening is not exactly how brain does that. That is where the fundamental difference is. the generation in this case is happening by means of that's a mathematical way of doing that. It's simply to explain it quickly. So suppose we have a distribution of points, right? We have a distribution of data points, and so suppose one is minus 3 comma minus 3 in a 2D space, minus 3 comma minus 3 minus 3 comma minus 2. This way we have all the points, right? So if you try to sample out some data out of these distribution of data points that is very interior to the distribution itself, right, which is not very much away from the distribution, that would suggest that it would have the same property as these points. But it was not the actual data point. It was not the actual points on which it was trained. It is generated, it is synthesized. So that is how these language models actually work on the generative space. Be it not just language models, I shouldn't use that term, just generative models to be precise. Be it encoders, most of them are encoder decoder models, be it traditional encoder or traditional autoencoder, these models. Whereas brain generates that by how to say that? I mean, by connecting events. Like suppose I'm seeing something. Suppose I'm seeing red. Okay. Suppose I'm seeing red whenever I'm going by road. I'm seeing the signal that is red, and for the first time I saw that I saw that the cars had stopped. All the cars stopped. All the cars stopped. Next time again when I'm seeing red, I know all the cars stopped. So these are two events. I'm seeing the car stop. I'm seeing the red happening on the flashing on the screen. So these are two events. So according to also we should use this thing here. So according to the Hebbian theory, basically, neurons that fire together wire together. Right? So these two neurons keep on firing at the same time. So now whenever I see red, suppose in somewhere else, I might be reminded of that. Right? I might be reminded that car should stop. But again, there is some more reference to that. Might not be exactly on the screen. So there are some properties that are not exactly how it was displayed on the traffic signal, right? This time. So might be somewhere else I see red. So that way it connects between two events, connects between three events, connects between multiple events at the end, and it picks up which one to take based on suppose I see again and in another traffic signal I see the red glowing, and I this time know the car should stop, right? But when I see red in someone's shirt or someone, that traffic car stopping, that neural pathway wouldn't fire that much this time. Might fire a little, but wouldn't fire that much. So based on that, this measurements of how much this neural pathway is firing, the generation happens that way. I might take up this, right? I might take up. I mean, from this neural pathway, I might take up some information and I might add this there. But when I see in someone's shirt, I might not say that the car should stop this time.
Well, you also have an inner dialogue, right? You tell yourself. So I mean, my experience of this is anyway, I see something and then I create a theory from it, right? I create a theory. This is, I think, what Noam
Yeah.
Chomsky is referring to. This is, I see a red light, and
Yeah.
it's not that I'm just seeing the statistical in this particular area of my eyes. I see the red light and I know this must be because of the car stop. That's what a neural network would do,
Exactly.
but my mind would not do that.
Exactly. I mean that. Yeah. I mean that is why you see arts, humanities, metaphors, similes, such relations would it's very natural to humans.
Yes.
Right. So even two things that are not very much connected. Suppose a dead shirt, or in this example itself, car stopping is not related, but maybe in a poem I might connect them together.
Yes.
Right? While ChatGPT or these kinds of LLM models might have not seen that in the in the large corpus of text, and sampling them out based on distribution would be tough in that way.
Yeah, exactly. Well, they also never felt or saw the color red the way that we see it, right? So this is another thing, and
Yeah.
that relates to consciousness. We are different from them in the sense that we have consciousness and they do not, even if they pretend to have it. They have not felt the wind in their hair or have not seen the color red. In reality, they might have seen some frequencies or some numbers that were related to them via some input sources, but they don't have an experience. And I think that this relates to this as well, right? So if you were to know exactly how the brain does it, do you think we would have consciousness, or do you think that consciousness itself is I see that there are two schools of thought here. One is that the brain does produce consciousness, and one is that consciousness is a fundamental property of the universe that is somehow channeled by the brain. So these are different views, but it is interesting to note that there is no difference between, as far as we can tell with our instruments, we cannot measure any difference between the conscious and the unconscious brain, and that's quite something. So do you think that that this is significant at all, this consciousness? And do you think that this is something we should worry about, and that's why we should build more brain-like architectures rather than just brain-inspired architectures? Do you think we should build conscious machines?
Yeah, I mean, yeah, definitely that is a very prime question. So how I see it is like these schools of thoughts, like one where consciousness is a product from brain, and where consciousness is something that is in our nature. These are two schools of thought. So I think the one it basically stems down to it's exactly like viewing brain itself from a neuroscientific point of view, using neuroscience, and from a psychological point of view, right? So I totally go with the scientific part of it, right? So I prefer to see that whatever we are seeing, whatever we are experiencing, whatever we are remembering, whatever is triggering next time. So this makes me conscious. We can put a term to it. We can say it that we are conscious that way, because we are being able to understand the past, present, as well as the future. Right? So we are there, but there is a science to it. There is science in the way that it's the neurons that does that. So for every event that happens, right? However I experience it, however I take that as an input, be it using eyes, be it using ears, or any of the five sense organs, that maps to a neural pathway. There is an encoding. There is an encoding happening with the electrical impulses, and so for each kind of event, there is this mapping inside my brain, and there are some neural pathways for that. So the question is, are there neural pathways? By birth? No. That neural pathways keep on developing. Right? If you do not see an event, or if you do not see a person for a very long time, that neural pathway will gradually degenerate also. The synapses will be removed, will gradually diminish, and the neural pathway will go on. So consciousness, to say that it is from by birth or from nature, that wouldn't be, I mean, a very correct way of saying, a very correct statement, to be very precise. It's evolutionary, it's developmental. It's based on what we see, what we have seen in the past, and how we relate to them, and it's all credit to the neurons.
But there's this difference between intelligence and consciousness, right? So you could have, in theory, I mean, not just in theory, but also in practice, you could have someone who is highly conscious of or not of themselves and of their environment, but at the same time cannot calculate anything, say anything, even speak the language, do anything behaviorally that is very interesting, but be extremely conscious. And on the same time, you could have someone who is very intelligent, like ChatGPT is rather intelligent, right? It sort of seems intelligent. It could probably pass some IQ tests. I mean, at least the newer versions, GPT-4 or maybe GPT-5 will be able to do it. But at the same time, they don't have an inner story, right? They don't have an experience. So I think that this difference between intelligence and experience is one that's really important. And so, because I think also for ethics, right? So when we decide even for abortions, the discussion often is, but when does it feel pain, right? When does it start feeling pain? When is it conscious? When does it start feeling things and and feel as a self in a way, as an entity, distinguishes itself from the environment? When does that happen, right? And not when does it start playing piano or when can it beat me at chess? Those are totally different questions. They're on a different axis, as I see it, right? So the intelligence and consciousness seem to be not necessarily that related. You see, like in religious experience is could be like a strong conscious experience, but it might not be all that intelligent sometimes. So,
Mm. Yeah, on that front, what I have to say is, I mean, and I mean, intelligence is something how I have tried to like put it, or also, works basically is the ability simply to detect and predict. So a person we say is intelligent, or by that matter, any living creature is said to be intelligent if it can see something that it is there by the sense organs and everything, and then it can predict what should I do with that next, and that comes from the training. Like suppose I have used laptop for several years and I see the key now. I know that I need to press this. Right? If I had not used this, I can detect, but I will not be able to predict. So that is how it relates to consciousness. So I'm in the state. I'm conscious of the fact that there's a laptop, and then I'm being able to predict that. Predict what should I do with this. So again, to be very to be to put it correctly, it's I mean nothing would be there basically if we hadn't been able to perceive that in our brain, right?
I don't know.
So
You have a chess playing
I mean
algorithm, right? You can have a chess playing algorithm that understands exactly what to do with all of the pieces on the chessboard to beat you, but it has no experience at all, and even has no real reason to play chess at all.
yeah. Yeah. So that is very much programmed. I mean, that is very much. So suppose there is this rule and it sees that okay, next time when this is the condition, I shouldn't do this. I shouldn't. So it keeps on training itself. But the point is, it would not be able to like do a lot of things at the same time, and that is the scene also we see that just like the example I said. So two things fire. So two things fire at the same time, and we are being able to relate that. So multifunctional roles and being an overall kind of an overall mechanism that is very that is very innate to how human intelligence works, or that for that matter most advanced animal intelligence
But you have
works.
self-driving cars, right? So, for example, that can drive better than I that can drive better than the best human drivers can drive already. And so, or maybe not exactly already, but in 10 minutes from now, right? And so, how do you explain that, right? So to me, and that car could have in it chat GPT, built into it. And then it can also talk to you now. And then you have, text to voice. And then it can also speak to you directly with the voice. And now the human imitation gets better and better. So I don't know that this behavioral answer captures it all. So what I'm saying is that even if I'm behaving exactly like myself, if you see something that exactly behaves like me and you predict everything I do, and it will do exactly the same things, but it isn't actually conscious. It has no inner story. It has no inner experiences, and it cannot feel the wind in its face. I think there's a big difference there in this thing, and that is not explainable by behavior. So that's what I think is the interesting part here, is that there is something very important. It's what ethics is built on. If it's not conscious, you can blow it up. It's not a crime if it's yours. If it's not yours, it's property damage. But it's not. You see, it's not a murder. Murder, it becomes murder if it's conscious, I think, so that's very interesting here, because I think if you're building brain-like architectures, you might actually build something conscious, right? That's the question. I don't know. Do you think that's true? Do you think that it will develop its own inner stories and feel the wind in its face?
Yeah, and from the point you started, right, self-driving cars. So that brings me to a very important point. So you know why? In most of these uni-purpose, like there is one, not multifunctional roles. So self-driving cars drive very well, right?
Yeah.
So that is a boon actually. So why is that? Because compared to, we have only one brain here, right? And so based on that, suppose I am driving something and I am seeing, suppose a phone comes or something comes, the same brain is again taking that also.
Yes.
Right? So while my driving, for that, those neural pathways were being already hiked, or they were already functional. This thing, the phone ring also, the neural pathway that is there for that phone ring, that also now hikes, right? So the overall mapping now changes, and it's not remaining just the brain or the model or the neural pathway for driving. Whereas in the other case, in self-driving cars, it won't get distracted.
Yeah, but I don't see the
So
significance.
that is actually a very important.
I don't see the significance of it, because if you can behaviorally produce the same kind of phenomenon like a human being, you could build a robot, right? And you could put into it a module that drives, a module that speaks perfectly well, reasons perfectly well, can do math, can solve proofs. You can put all these modules in there, and it'll behave much more intelligently than any one of us, because it can solve any one of the problems.
But then again, you cannot. Yeah, but then again, you cannot relate in between two. That is the trade-off that I'm talking about.
You cannot relate.
So suppose you.
What do you mean?
Yeah. So suppose suppose there is a part that talks or is related to speech, and there is a part that is related to seeing, right? Vision. So now, how does it work in brain? These are not separate. So when I am seeing something and the person is talking, suppose I am seeing a person, the person is talking. So I am seeing that person with my eye, and immediately at that instant, I am also hearing the person's voice with my ears. So both the neurons, both the neural pathways are firing at the same time. So that would not be the case if I create two different models.
No, but you can easily, right now, you can have a YouTube, let's say, add-on, or some kind of, video intelligence that can tell you, oh, there's Johannes right there, he's talking, and it can do it all in real time already. You can even say, oh, now he's smiling a little bit. He's got
subtitles.
So you have all of that already.
That
In a way, you have that already, right? And then you can even translate it into Italian if at the same time, in real time, almost.
Yeah, but you again know that the trade-off for that, it's generative, right? How we just explained, how we just caught upon it. So it would still be that kind of that kind of a distribution-based generation.
Yeah, so the mechanism will be different, but observably, what we observe will be the same, right? So it can even outperform us in terms of observable performance in almost, in many tasks it can. Well, it beats the best chess player. It can, beat the, so it can outperform us in some dimensions for sure.
in unidirectional tasks, in one purpose tasks, that in most cases
Yeah,
that
but
would be
what
the
what
case.
I'm saying is,
If we are building something.
what I'm saying is, if you stick them together, like from the observation, you will not observe that there are five different modules working at the same time, and the exchange of information is extremely fast between them. So it's not observably different, right? So that's my point is basically when you look at the thing, if you can mimic a body, if you can build something like a human body, oh God, we will be there at some point. You stick all of these modules in there, and it will behave like a very smart human being. You agree? And so that's what I'm saying. So what is the significance other than consciousness, aside from consciousness, which is, I think very important, but the significance of, aside from that, in terms of behavior, I don't think there is any in terms of thinking, I mean, yes, it took a lot more data to train that thing than takes to train me, because I see two cats and one dog and I know, oh, this is a cat and this is a dog. This machine has to look at, I don't know, thousands and thousands of videos. But in the end result, once you train it all up and you look at the behavior of the machine, can you differentiate between it and the human? I don't think so.
Now, what you just spoke about, like if we try to attach all those modules together, it would be as smart as humans. That is true. So if we try to attach all those modules together, what we're essentially doing is we are trying to put the neural pathways together. It's equivalent to that. Right. So if we are trying to create a computational model that is same as the brain, so definitely at some point it would be as smart as the human. So if we attach it in this way that once this neural pathway fires, this neural pathway should also fire, and both the neural pathways can fire at the same time, can take the inputs at the same time. That is doable, and that is what the objective is for many
Yeah, but
people right
see,
now.
there's still
I mean,
something
if
very
you
different
see at
about it, right? I mean, even though observably you get the same results, but what Noam Chomsky is saying about the lumbering statistical machine that is trying to please you. So the one thing you will find is that it will please some average person or someone who's trained them. It'll have an opinion even, but the problem is that this is not the way that we work. Even if you fire them at the same time, I will argue this is not how we work. We like Noam Chomsky says, we make sense of the world. We try to explain it. This is how we learn. Right? We manipulate things in our head in this way, and so and we don't look at thousands of cows and thousands of kangaroos and then know, oh, this is a kangaroo and this is a cow. We don't need thousands of them. So we have a different machinery, but observably, I think observationally, and this I think is frightening, in fact, because I think what you're building is a zombie, something with no consciousness. Uh, uh, but but um, but observationally, when you look at the two entities, they can actually behave frighteningly alike, and maybe one better than the other, and the one that has no consciousness being the one that's better. So, what do you think of this? Don't you think that the main reason to rebuild the brain or to build something much more brain-like is and I don't think it's even reducible to the firing of neurons. I think there are other things going on in the brain, chemically, electrically, aside from what we're modeling there, that produces consciousness. That has nothing to do with computation.
okay, no, I mean, what essentially happens in the brains if you even do it electrically or chemically, it's the results is the firing of the neurons. So if there is an electrical exchange, I mean, from one neuron to the other, that is basically the
I
firing.
understand
And
that, yes.
what aids that what aids that is basically the chemical transactions in between, the ions coming in, coming out. How at what input, how many ions should come, or what should be the potential there with respect potential inside the cell with respect to the outside of the cell. these things is the chemical transactions, and with respect to that, this is the electrical impulses go from one neuron to the other. And that is how the neural pathways are built, one neuron to the second, to the third, this way. So how again we like I mean how are we saying that we are conscious? We say we are conscious um, because we are being able to relate past with present with the future, right? Is that a sentence you would like to agree on? Then I can proceed with
No, I wouldn't say it's just
explaining
that.
that
I
sentence.
think that neural networks and even I think that even ChatGPT could do that already. It could lay out a history of, you could ask it about the history of Europe and it will tell you all the different time periods and so. But I think the difference is really in this experience, in the qualia, in not just the qualia. I mean, maybe that's even I think that's even not right. There's this conscious field. I think this is how it has been described. The conscious field is that you relate to. People break it down, the ego and the it and so on. There are breakdowns and psychological breakdowns of it, but the fact that you experience your environment and you realize that you are, you're Srijit and not someone else. You're not me. You're you, right? And you and that identity is this fact that you're experiencing the world, right? I think that makes all the difference. And I don't know that it's a computation at all, to be honest. I think that the computation, so the way that Utpal thought of it is basically that the mind is feeding consciousness all of its experiences, and all of that is computational. So essentially, there is a subject inside of you, or whatever, however it is, however it gets there. That's the interesting part. I don't know how it gets there, but we are subjects. We're not objects, right? We're thinking, but we're not just thinking. We're conscious. So I think this is the ultimate difference that Descartes even had wrong, right? The fact that what makes us ethical objects, what makes us the object of ethical discussions of what is the good thing and what's the bad thing to do and so on, all of that requires consciousness. So it is about conscious objects, conscious objects that we call subjects. So we call them subjects. They have subjective experiences, and because of that they're significant, they're ethically significant. Otherwise they would not be. And this consciousness happens even with people who are very still and do not, where you cannot observe any behavior from them at all when they meditate. In fact, it is said that the consciousness is heightened, whatever that means. Exactly what that means is not clear to me. But you certainly have different experiences, and there are some things that are going on in the brain when you meditate and all of that. And those are computational processes, and I agree with that. But the subject that is in there, I don't know that it's a computational process. I think there's something else going on either in the brain, and it might not even be a process. It might be a still thing, a thing that's rather still, that that produces this effect, if you will, that everything else depends on.
I mean, I do not see it from a divine point
No,
of
no,
view
no, I'm not saying
scientifically.
that either. We can study it scientifically, but what I
Yes,
don't agree
exactly.
is
So
that it's computation. So I think there's another process or a thing in there somewhere. Maybe not only in the brain; it could also be partially in whatever, the whole body. In fact, we know that neurons are firing all over the body, including the gut in particular. But so I'm not sure where this thing is located or if there is a location of it at all. But it is some process or some organ, some part of the brain organ, likely is what John Searle attributes it to the brain. He just says something in the brain that produces it, but he doesn't necessarily know that it's always the firing of the neurons, which I think is responsible for intelligence. The firing of the neurons is probably
no, I mean
responsible for intelligence.
it's not actually it's not actually always the firing. What the point is that each time the neural pathways gets formed is, so for creating a neural pathway we need a series of neurons, right? So there we need the firing from one neuron to the other, right? And from next neuron to the upcoming. But even if the neurons don't fire, even if the neurons don't, suppose the neuron is not firing, but still I'm giving some input, and there is some rise in the what is called the potential there inside the cell. So maybe that is not crossing the threshold, but there is a spike there, and that is also a part of the mapping for this particular thing that was the input. So for there is no need of that kind of firing, but yes, the neurons should have this potential, this changes in potential, and that is how for each kind of an object outside, or for each kind of an experience outside, there is a unique embedding, or how we call it, encoding or mapping in the brain as well, in combinations of neurons. So what is what yeah, or what I want to say is, I mean, very much is, what is very fascinating is, I mean, whatever we see right now, right? Suppose we build a building, or we build an office building, we have created a park or anything. Some person before doing that thinks about that, right? That this way I will build it. So even before building it, there is a data that is inside, and we create that, we recreate that. So these are some experiences that we have taken from outside, and based on that data, we are again creating new data, generating new data inside our brain, and we are again recreating that
but
the
this is
outside
not
world.
entirely true, right? We know this also from Noam Chomsky. So even in the beginning of our life, before we even have any experiences at all, we must have some potential for language learning, which is very unique. So and this is different from ChatGPT and these kind of tools, because, and this is what his argument is, these guys would also work on languages that are impossible for humans. So there's a range of things that are possible for humans, and it is based on something in the brain, for sure, something that develops in the brain, something that evolved in the brain, but it is pre-coded, it's hard-coded, it's already there. So I think that a lot of things that make us who we are, the shortcuts that we can take, are hard coded even before. So this is the nature nurture debate, and I've read a lot of books on this, and Steven Pinker even agrees with me on this one, where he probably wouldn't agree with me on the consciousness one, which is, I think they have a little bit of a funny idea there. But in terms of the fact that we have a lot of innate abilities that we don't fully understand yet, we are much more efficient computers than those machines that we're building. That's also part of it, right? So as you're saying, it's neural pathways. It's definitely that is all true for what I think is the mind, the machinery that makes us pretty efficient at learning driving and all of these things, where these machines have to learn this. They have to drive thousands and thousands of miles, either in simulation or in reality, before they can drive anything at all. And we can do it pretty quickly. And all of this has to do with a combination of what you said, that this neural pathway learning mechanism is better, it's more efficient. And then also because there is already so much architecture built in to begin with, all of our drives, all of our, the drive to survive, the drive to have children, all of these kind of instincts that we have, right? They're also built in, and AI will not have that. So it's a kind of
These are basically yeah. I mean, these are basically part of how the human body is. That would be this. That we can't deny that. No way. So I mean, the hormones exist, and so all the urges, all the drives. That are basically, I mean, how the human body works. But all the developmental things, on the other hand, that we pick up on the process from experiences. These creates these pathways that we are talking about, the learning part. That is true.
Yeah, but so you're focusing on the learning mechanism, and I think that's very good. And I think you're right that it can become more efficient. I think liquid neural networks. Have I asked you about those yet? They've been inspired by biological brains. I don't know the name of this worm, but it's a little worm, and it's very much built as a copy of it, a digital copy of it, essentially. and it has fascinating properties, and then it can rewire its architecture relatively quickly and learn new things rather quickly compared to previous neural networks. So there's some work there. Are you aware of this? And what do you think of this work?
Yeah, I mean, I mean, when we talk about these, any kind of such neural networks that are, I mean, biologically very much accurate, right? So we start from the first thing that started with, we started with in this field was the spiking neural networks, right? So, I mean, the spiking neural networks, we got in conventional deep neural networks, the weights are very discrete, right? Whereas just as we talked about right now, in brains might not be firing, but still there is a little spike, and when there is a removal of that input, the spike drops, and there is a removal of, I mean, again that push of that input, and there is again that spike, and also the intensity of the input matters, not just how many times or how many this. If it's high intense, maybe just one time might give a very high spike. So based on that, how spiking neural networks work is very much close to the brains. So I mean, I've seen this work actually, like why this is something that I very much enjoy discussing and talking about is I've seen this kind of this kind of an implementation in the hardware while I'm doing my masters, right? And in the lab where I was doing masters, my professor there and everyone, the team was very. We had a hardware lab. We're trying to put these things inside the idea of spiking neural networks inside membristors. So if I don't know, like there is a certain fascination about, I mean, there is a certain good thing about memristors. So memristors are if you know about this, it's not very much popular as compared to registers, but the why this thing is very much relevant in the world of creating the brain-like structures is basically it holds that resistance, right? So suppose you pass a current or something, you pass a current or something, there's a resistance which is very much fixed to which is very much static to or to the property to that particular component, to that particular material or the weight or that thing. Whereas memristors, it keeps on, it depends on the current as well, right? So if the current this time is increasing, so it keeps how much the resistance was previous time. Based on that, when the current I pass next time, it helps the current to pass next time, right? So there is a training inside this hardware, which is very much interesting. So that is what we saw. We worked on these memristors and those things, and so I have seen several people, like it's my very good fortune, I'd say, that I've been able to work with. I've seen some very good people working in the areas of AGI, to be very precise, doing masters, and after that also currently, if you've heard of this lab called Numenta, right? So it's in it was, I think, previously called Redwood Center for Neuroscience or Lab for Neuroscience previously. So the inventor of Palm Top, Jeff Hawkins. So he was initially built the Palm Top, and then he was very focused in neuroscience. He doesn't have a formal degree in neuroscience, but it's very fascinating when we get to hear from him how what kind of computational models should be there with respect to brains. So he talks about a very, which is not something that I have been talking about right now. It includes a macro level as well. What are the layers of the brains, right? So it's called hierarchical temporal memory, HTM, right? So that is something where exactly. So what we have been talking about so far is on a neuronal level. So how neurons, that learning, electrical impulses through the neuron helps in learning. So it is also important that how we place these neurons inside the brain. What are the locations? Which part of the brain is for which thing? Which part is for the other thing? So that is the kind of thing that is a very important concept in HTM, hierarchical temporal memory. So I follow that lab very closely whenever there is a newsletter or something. So yeah, very few people working on this, but I'm surely a very big supporter of AGI and
Yeah.
brain accurate.
What do you think of this? So John Searle makes this argument, right? So if we simulate fire, we're never afraid when you look at the computer and you look at a simulation of fire that it's going to get hot, or that, you know, if you simulate explosions, you're not going to step away from your computer every time you press the button, right? There is a causal effect that is missing from a simulation to from that sort of simulation in our world or in our simulation. Some people think we're in a simulation, but maybe we are. But if we are, then we are on a higher level of it. That when we simulate something in our computers, we're not reproducing them, right? So if we want to fly from London to New York, we will go to a plane, right? We will not simulate it on our computer and hope that we're going to get to New York that way. So in that way, simulation, do you think simulation is sufficient to really reproduce something like the brain, or do we need to actually build physical things? Because so also even the way that the brain works, when we're then starting to look at the chemicals, the neurons don't just fire or not fire. They're not just zero and one, like you said. They're also not just continuous or spiky, but there's something else to it. They have multiple chemicals that are not just one chemical, but multiple chemicals that can affect it. And in fact, you know, if you take certain drugs or certain stimulants or certain chemicals, they will have a direct effect on your brain, and you will have very different type of consciousness. In fact, so how do you think that we're working at all in this direction, or is it just simply the one-dimensional? Because I think at the moment this is still very one-dimensional, right? It's firing a little stronger, a little less stronger, makes an imprint, makes no imprint, but it doesn't, or makes a stronger imprint, maybe a degree question, but not one of 3 or 4 different chemicals having different effects at different times. What do you say to that?
Yeah, so there are two questions here as I perceive it. One is simulations, right? Will are simulations enough? That is a very valid, very valid question actually. So what, like, I think it depends on the infrastructure. So I mean. Yeah, so it depends on in how many dimensions are we being able to simulate. So suppose as you said, like there's an explosion or something, so we do not get frightened, or we do not. So it's basically because it also depends on how we feel it on our skin, how it sounds. Maybe sound can be done in simulation, but all the features are not at this scenario involved in the simulation. Olfactory senses, this touch senses, these kinds of senses still needs to be evolved to very large degrees, which is not the case right now. So currently, that is a trade-off that we face also in our I mean, in the kind of development work that we do. But going forward, I mean, I've seen some good developments in the olfactory, senses. So there is computer vision right now. There is natural language processing right now. Computer vision, it's basically how we see it. So sound, speech processing, these things, right? So when we can also make smell also a valid feature for computers to be able to perceive that would be one more step ahead in the simulation. So
But
I
even if we
feel
had
hopeful
that,
for it.
we still couldn't go to New York based on that, right? So we would still go to the airport, to the real airport, go into a real plane, and really fly
Yeah,
to New York. It's not
that is
possible in a
geographically.
simulation, right? So this is
True.
what, what John Searle makes this comment, and he says that's the difference really between what we're doing when we're simulating the brain. When we are really, what we really need to do is we need to reproduce the causal powers of the brain, and only then will we have consciousness.
So here comes the question of the very question of metaverse, right? So even sitting here, can I see London or can I see Antarctica or any such thing? So currently, no. Can we experience Antarctica as it is, as good as if we had gone there by sitting here itself in metaverse? No, because we cannot simulate to 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 include all the features, all the five kinds of features to exact ditto that level. But if we can do that, then there is very much hope in that direction.
But
Yeah.
that still would be different, right? Because I mean, you're saying that if I wanted to be in San Francisco, I could simply go put on some helmet and experience San Francisco, but I can't just go to a meeting in San Francisco and knock on someone's door and say, "Here I am." That's still a difference, right? I mean, there is a real place
Ah,
called San Francisco.
that is geography. So what we can at most do is maybe we cannot. I mean, what we can at most do is to try to create the perception of it, try to create the
Yes,
inner mapping of it.
you
That
see,
that's
and
the
this is,
most
I
we
think
can, we
that
can do.
yes, in a simulation, right? And so then, what if you do this and you expect this to building a consciousness? And you can say, well, what we can do at most is to create a perception of consciousness, and we can do that probably quite accurately. But I think we cannot actually build the real thing unless we build something that has the same causal powers of the brain. And I think that I'm with John Searle there, or I'm not sure because it could also be true that that consciousness is simply a something like radio signals, right? So something different, like similar to that, where the brain is simply a receptor of it and doesn't produce it at all. I think that's still a very scientific possibility that there are such things like radio or you and I, we can speak here on this phone, and it's all based on things we cannot see, right? There are whatever 5G waves or whatever that gets us from one to a receptive tower, and then from there it sends it up to some satellite, right? All of these things are not. If you didn't know about this, you would think that that's magic. But so similar to consciousness, we don't know how it works, so we think it's a mystical, spiritual, or we look for the Vedas to answer that question. So maybe there's something real in them actually as well. I'm not even doubting that, but to say that just because we don't understand it means it cannot be scientific, I think is also not true. It's just that we cannot currently understand it, right? Our science couldn't understand radio waves 200 years ago. We didn't understand anything, and so now we don't understand consciousness.
No, no, it's very much understandable. It's scientific. There is no doubt about it. So
Yeah,
how we see it is basically from the beings. Yeah.
yeah. But just to say that it's not neurons that are doing it, it's not to say that it's not scientific, right? It can be something else. That's all I'm saying. And I think that's what I think the causal powers, there is this difference. We can simulate, apparently we can simulate intelligent behavior. And that's amazing. That is something I would not have thought. I must admit, I would not have guessed this. But we can do it. But consciousness, can we simulate it, or do we have to build a machine? Do we have to build a particular instant? So the question really is it substrate free? So can it be done in a way that is devoid of any material replication of a specific type?
Mm, no, Again, like I'd like to iterate on this part itself, like how I see it. Still, it's evolution. Um, any kind of any kind of action or any kind of thing that you keep on building, right? So you give an input, you give an input, you give an input. Next time you know that this was this. So how do you, when we say about consciousness, are we saying about we, if we are seeing it in this respect that we are conscious because I know that I exist, right? I'm aware of myself. That kind of a notion. Then also brain comes in between, right? I have my experiences. Any person has their own experiences with different objects, different things, and he can relate to all those experiences. At the same time, there's a he can. I mean, there is he in all those stories, he or she, in all. So, I mean, yeah, it's all. I mean, it's captivated in the brain in all these instances, and how that is already that is spoken about so far.
But in neuroscientists don't fully understand it yet, right? And there are two approaches, in fact, there. One being the study of a conscious field approach, which I prefer. I think this is a more probably the better one. And then there's this other one that tries to understand qualia, which is this idea of individual experiences. You know, how does a human experience the color red? How does that work, that mechanism? But I think that once we understand the conscious field, is, how is there this I there? How does this happen? This experience of the self and the experience of the world. Once we understand that, we probably will understand these other things in a more, pretty easily. Like once we understand, how this conscious field is there, then, how to experience the color red is probably going to be trivial compared to figuring out how this whole self got in there to begin with. Do you think it's dangerous that if, like, do you think it's dangerous to build machines that are not conscious and to build them in such a way that they're indistinguishable from conscious entities?
How I see it is, it would be actually, when we say indistinguishable, it would be actually indistinguishable. That is, we cannot say whether it is a human or it is a machine. Is going the brain way. Right? If we try to compute, try to create a model that works brain. So in that respect, we can then we can say that exactly these are two things. So, I mean, with that respect, so there is no such danger, because creating humans also has its own trade-offs, right? We exist, we coexist, right? I am I'm a very positive kind of a person. So, right. So,
Well, I
yeah, I
challenge
mean,
you on this one because, on this indistinguishable one, this is Turing's hypothesis, right? So Turing put forth this idea that we could test whether a machine is conscious by asking them certain questions, and by, once we feel that they're human, once we detect them to be human, they must be like that. They must be conscious. But it turns out that this test has been passed by machines that I am very sure are not conscious. So ChatGPT has passed, basically. Well, the GPT-4 for sure has passed this test, and others. I think there was a Googler who was fired because he said that the chatbot was sentient. But I am very sure that it is not sentient, but it behaves linguistically, the way we speak, it behaves as if it was conscious, right? And it is impossible, and it becomes even more impossible over time as they get better, to tell the difference by testing it, by interacting with it, by poking it, by asking it interesting questions, or even questions of the theory of mind and so on. They will pass all of that because it is, because that's how humans talk when they talk, and it has so many texts to refer to. It can simply produce the statistical patterns that a conscious human being would produce in response to ask questions and so on. And very likely we will be able to do the same thing with little face twitches, little smiles. We're already quite there. There's a frightening video of such a virtual human who has passed the Turing test and all the derivatives of it, too, all the different theories that might be used to test consciousness, all passed it, and it yet is not conscious. So I'm there. That is the thing that I'm frightened about, because I think that if you fall in love with a statistical machine, then you don't know it. I think that's ethically that's completely wrong. We should never be misled to live lives with meaning, try to create meaningful relationships with things that have no meaning, that have no internal semantics, that don't understand the world as an experienced world, but only one of a statistical correlations kind of world. And I think it's amazing that we can do it. It's frightening. It's definitely disproves some of my hypotheses, but I still don't think. What do you think of that when I pose it to you this
No,
way?
yeah. So no, I do not see any kind of a. I mean, when suppose we are creating something, right? We are creating something very much for one purpose, as I'm saying. So again and again. So we are creating something for one particular purpose. It is designed not to get distracted. It is designed not to get other neural pathways, or however its intelligence is, its mode of intelligence is, to it's designed not to include other data at that time, and not to act with respect to other data.
Hold on, because I can read to you what it says here on OpenAI, what it says about it. And they are saying the opposite. They're saying, in fact, that they want as many use cases as possible to be tried out on the same algorithm, and that they're now, the GPT-4 is basically their attempt to get closer to AGI. And they want to use the same model to solve a lot of different problems. Like, for example, manage a company. It might be able to manage a company. In fact, in China, there is a company now that has made an algorithm their CEO, and it's beating the stock markets. So this is actually not quite the way that you're saying, because
Let me clear this. So, what do we mean by use cases in that case is, so they have, I mean, there's a language model, or not just language model. It's a pipeline basically. It's a such that it's conversational, generative, contextual. So based on that, we can create a number of things that has the same inner working, and based on top of that, we can create a number of things. Like, for instance, when there was this language model BERT or these things, there is always this option to create either a question answering model, question answering kind of a pipeline, sentiment analysis kind of a pipeline. So even on one particular thing, we can create different use cases. They're also aiming that, because currently chat GPT or GPT-4 or the generative pre-trained transformer models have I mean, they have been on the site, right? They have been on their site, and not been used too much by the general public or the corporations or anything. So with the advent of this chat GPT, and with the popularity that it has gained, and it's really fascinating to see the kind of intelligence, whatever be the process had been followed, but it's still a kind of intelligence, be it a statistical, it's not statistical there, it's more than that, but whatever kind of intelligence it is, so it's good to see that. And based on that, we are more open to using that. They're also more open to let us use that. On that context, there will be a lot of use cases of this GPT models. Yes.
yes. So, I mean, I think in this indistinguishability between the human and them, it gets tough. I mean, if you can do your accounting better than your accountant can do it, then what is that? That is a replacement directly of a particular job, of a particular human being, right? It can answer emails, it can do all of those things. Could you leave? I would love it if you could say something to the audience, something you would leave them an impression with. It was a little bit of a debate. It was interesting. It would be great if
Yeah,
you
I
could.
mean, to be very honest, I love debates more than conversations. So we get to see the best sides of both the people in dialogue.
True.
Or else, to be true, like it's like someone is ready with some questions and he wants answers. So we do not see both the sides giving I mean trying their best to give justice to a particular topic, right?
So, what would you like the audience to take away from this discussion, and also how would they keep in touch with you and follow your research?
Yeah, so I mean, you can, and I'm very much active on LinkedIn, and that is the media I like. So you can always reach out to me on LinkedIn. Very much available, not an issue. Following my research, I publish my articles on, I mean, whatever research I do, that is on ResearchGate. So that is available, and from a message perspective, I what I like to say is to remain hopeful, to remain hopeful always, and at least I like to see things not on a very surface level, but to on a very deep scientific level. So to try to analyze everything possible on a scientific from a scientific perspective.
This show is published every Wednesday at 10 a.m. in the United Kingdom, 5 a.m. on the East Coast, 2 a.m. on the West Coast. Please leave us comments and tell us what you like, the direction of the show, if you like the direction, if you don't like the direction, if you want to see something in particular on the show, please tell us. Subscribe if you haven't already, so that you can keep current with the show, and give us as many comments as possible. And also give us a thumbs up on things that you like.